Okay, so it's a minute past. So there were people joining bit by bit, so I've been letting them in. This session is session 3D. When it comes to doing your feedback for this session, it's 3D. You can access the feedback from your Bring Your Own Agenda. That's the simplest way. This session is being hosted by Chris Walker and Nicole Kamara, and I'll leave it to them to introduce themselves. If you have any questions, please can you put them in the chat, and if it seems a relevant time, I'll try and interrupt, but otherwise we can save them till the end. At the end, I will allow you to unmute yourselves to ask questions and chat directly with Chris and Nicole. So without further ado, over to the two of you.
Okay, good afternoon, everyone. My name is Chris Walker. I am one of the product managers within IBM's excuse me, Z AI Ops portfolio. And I've got my colleague, Nicole Kamara, with me as well. We're going to run through a session around the whole topic of enterprise observability. We're going to go into a little bit around what observability is, why it's important today, why it's different from some of the other things such as monitoring, APM, slight subtle differences between them, and why it's important to have the mainframe as part of that story. A lot of good things around observability and out there, but incorporating the mainframe is critical for so many of our customers. So we're going to walk you through why that's important and how it's possible today. We're going to be using IBM solution in this space, which is called Instana, but hopefully there's some interesting topics for you to learn about in terms of observability. So with that, I am going to hand it over to Nicole to get us started.
Awesome. So to start off, we just want to give a context as to what the mainframe is and how observability plays into that in this modern world and the hybrid cloud world. So when you have an app like PayPal or Zelle or Cash App, it all is integrated with around the mainframe, and it has the mainframe at the center. And the big thing to think about is how you want those transactions to be happening instantaneously. And the way that it is possible to do that is through the mainframe, but it's also interconnected with a lot of different systems in the hybrid cloud. So having an ability to monitor that and seeing how there is so much connection and integration between all of the different systems, the observability of each of them is very important. So we also have the mainframe's importance over the past few years. So we have the examples from way back when there was only in-person banks and transaction areas. And now we have like such an interconnected and virtual banking scenario. So we can see how the transactions between the hybrid cloud and the mainframe have grown exponentially, and can show how these transactions are so important and complex, so that observability is key in this scenario. We can also look at the challenges that having these very integrated and intricate applications cause. We have a lack of visibility into these applications in terms of how they're connected and how they are run, but also the complexity is growing with the visibility remaining low. So we kind of have a perfect storm of complex integration, and there's a lot of pressure to grow these different applications and have them deployed at a time in a timely manner versus having a lot of time and having it be able to go through a lot of different testing and observability testing. So now we have the evolution of application monitoring. So what we can see here is how it's changed over time. And so application monitoring started in the 1990s to 2005. And all this changed and started to create, it was all under one roof essentially. So everyone did all the work in-house, it was on-prem, and they were able to monitor these systems all together. And so it was pretty easy to keep all that together and understand everything just because it was in those on-prem situations. And then SOA and other technology advanced, so we started to gain visibility into how they could be connected outside of that on-prem model. And then today, we have all these different containers and microservices. So this is actually very helpful because it allows us to have it isolated. And so we can actually have observability and not have things break due to different updates in different areas. So having observability into those different containers allows those to grow. So what is observability? The key thing here is that it's logs, traces, and metrics, and you cannot have a full observability without all three. So if you have two of them, you don't have full observability. And this is key when you're looking at applications because all three of these things tend to interconnect in a way, and they do influence one another. So you'll often hear people talk about observability when they're talking about monitoring, but really it is understanding the traces, metrics, and logs of all of them. So traces is a record of the entire journey. So if you think about the topology of a application, you can see how it goes through a journey of a hybrid cloud and actually see what different areas it touches and kind of monitor the path that it goes on. And this is helpful, especially when you're looking for the root cause and want to be able to see how the mainframe is integrated in that as well. So logs are the actual timestamps of these transactions and different traces. So this allows you to kind of have a playback of what your application is doing over time. So this is helpful, especially when you want to see like slowdowns or different ways that it's stopped along the process, and can also help you with debugging as like the logs go through the path, and so you can really traverse the process and see how it goes throughout. Metrics is what we think about when we look at monitoring. So these are the actual numbers and actual measures of the application and its health. This could be the CPU capacity, which is a common one. And so these actually show you that in addition to like showing the health, that can also give you a measurable way of seeing your different baselines and understanding how your product works and what could be considered an abnormality. So when you look at observability across an application, it can impact multiple teams. As you can see, you have the application owner, the SREs, and the mainframe SMEs. So each of them have a different responsibility when it comes to maintaining the health and the full observability of an application. But they do not cross over into each other's areas. So these three personas, while they do all work together under the same umbrella, they have different responsibilities and have different capabilities in terms of their knowledge. So here shows how that application owner, SRE, and SME cover the different aspects of an application. So you can see there's not a ton of crossover when it comes to the mainframe and then the VMs, and then the application owner has a visibility into all of them, but they don't have the specific knowledge that would require them to fix something. So they just have visibility into seeing that there's an issue or being told that there's an issue versus actually being able to go into fixing it and seeing what the actual issue is caused. So we're going to go into a scenario that will explain how the absence of observability can harm an infrastructure, and then what end-to-end observability will actually look like. So here we have the absence of observability. So we can see on our tracing topology map that there is a slowdown on the mainframe coming from this specific node. And that node represents the mainframe, but we don't actually see any details as to what is underneath that. So we can't really drill down into that mainframe node and see what is going on and actually have an understanding of what within the mainframe could be causing a slowdown. So it creates a bottleneck for them to, in terms of understanding. So in this case, then the application owner would have to go to each different SME, and it kind of becomes sort of a firefighting drill and proving of innocence, because you're having to take time out of everyone's day to check their different aspects of the mainframe and see if it is their issue. So there isn't necessarily a problem with this method, but the time that it takes and the expense and the impact it makes on the infrastructure is a pain point. So while you will actually most likely get to the root cause of the issue, the time it takes and the pain that it would cause to the team in terms of time management is the main pain point that we're looking to mediate. So with end-to-end observability, this will show you actually what part of the mainframe is causing an issue. So in this example, it's a CICS region. And so you can see, instead of just going to that specific mainframe node, it actually gets to show you that it is a CICS issue and can actually drill down further into different information about this affected nodes. And so even the application owner can provide important details to the SMEs. So here we can see that the application owner can then go to the SME and actually tell them what CICS area and CICS task is causing an issue. So there's already that bit that is done for the SME when they inherit the task. But they can also drill down into those nodes and see different metrics pertaining to that area. So this is where you have your Omegamons integrated into these observability solutions. And this is how you can see like more information on how that observability can influence the SME, but also it allows the application owner and the SME to be more integrated. And I will now hand it to Chris.
Okay, thanks, Nicole. So hopefully, excuse me, hopefully that gave you a good overview of what observability is at a high level topic. I'm going to go to the next level down here. I'm going to show a demo in a second of this actually in action. And I'm going to be using IBM solution in the observability space, which is called Instana. So Instana itself isn't a mainframe tool. It isn't a Z tool specifically. It is enterprise-wide, and it's focused on lots of different domains and lots of different stakeholders within application performance management traditionally. So people from business, people from the DevOps team, IT operations generally. And Instana is a relatively young product. It's only 6-7 years old from initial concept. And it was initially focused on the new sort of breed of cloud-based workloads. So think of things such as containerized workloads, microservices, which traditional APM solutions were struggling to monitor and manage because a container may be spun up, used, destroyed within seconds. And so actually tracking and managing those workloads was really difficult. So Instana came in as a solution to trace every single application flow and give better visibility into that space. Now, IBM acquired Instana a couple of years ago, And what that has meant is that the investment that IBM has put in has grown the breadth of what Instana is covering. So it now covers many aspects of the IBM technology stack, like MQ. It also means that we're able to expand the full view of what we would call an enterprise application. So as Nicole was showing, it's not that the mainframe is siloed and isolated from the rest of the organization when it comes to workloads. We have the mainframe being driven by mobile front-end applications. Maybe there's some API enabled through ZOS Connect, ultimately driving a transaction in Kix or DB2. And so being able to manage that is critically important. So what we have done with our work with Instana is make sure that the mainframe, and ZOS in particular here, is a first-class participant of the whole observability story. So you can actually trace a transaction from, in quotes, mobile to mainframe. So that's what I'm going to show you as we go forward here. So I think that's your last slide, Nicole. So I'm going to, if you stop showing, and I will grab the screen and we'll start with a demo. And screen. Let's fire this up. Okay. So what I'm showing here is a application within Instana. And for those that may have not seen Instana, the layout is similar to other APM solutions. There's a lot of key information about what we're viewing here. So we're viewing an application. That's when I mean an application, I mean a composite hybrid application that's been defined in Instana to trace a particular flow through a system. Instrumentation of that application is relatively straightforward. There will be sensors, agents, data collectors installed on various systems. And they're looking out for different runtimes on those systems. And you will define within Instana a kind of an entry point or a starting point of the application, or profile of the application. And what you can then say is, I want you to trace all of the transactional flows downstream from that particular application. You can put more complicated rules in, but for simplicity's sake, let's say we define a starting endpoint, and we say let's trace everything from there. Now, what that means is that we're able to follow the flow of those applications as they go through the system. And as those systems are being investigated or traced, Instana will gather information about that and build up this topology map that you see here. So for this application, which was called Robot Shop, we can see the different flows through the system. We're also looking at certain time periods as well. So you can narrow in on maybe looking at the past hour, you can look at live data, you could look at the last 24 hours, but you want to be able to look at a period and understand who is a participant in that application over this time. And if there's any slowdowns, Instana will tell you that, the behavior that we're seeing through this application is now atypical of what we expect to see for this. So maybe, we see an end-to-end transaction flow of 1 second. It's now taking 3 seconds. So we're able to alert you to that issue. Now, this is similar to what Nicole was showing on the high-level use case beforehand. We've got a hybrid application here with lots of different nodes that have been identified by Instana. We can see here there's a payment application. We hover over, we can see it's Python. We've got a Tomcat server here. We've got RabbitMQ, lots of Node.js, lots of different things that are running off the mainframe. You can see that Instana has also highlighted certain nodes in red because it's seen that there's a change in behavior or some kind of problem here. And this path through here goes to this node here, which has got a host name here. We can see it's an HTTP request, but we don't really know too much about it. That actually represents the mainframe. So what we can see here is a good view of everything that's running outside of the mainframe, and then we see, oh, it called into the mainframe, there's a problem there, but we are lacking any kind of context as to what is going on inside the mainframe. And that's a problem, because the person who may be looking at this is going, well, I don't know what's going on in there. Is it calling through MQ to Kix? Is it calling MQ to Kix to DB2 or to vSAM? Who do I get involved there? And then, you know, if you don't know who to get involved, you have to get everyone involved. So that's the real challenge that we're hoping, or we've worked to try and overcome here, because as we are increasingly dependent on these applications that are touching the mainframe, we need to be able to identify the source of a problem quickly, get the right subject matter experts involved so that they can then resolve it before end users are impacted, customers are impacted by the problem with the application. So in this example here, we've got very little mainframe observability. What I'm going to show now is this exactly the same application, but with additional instrumentation put in here. So now we've got same application here. We've got this Tomcat server. It's now calling into Kix, and we can now see, hey, look, we called Kix here, and we know the Kix region that it went to, and we can see where it went to from Kix. We went to another Kix region, so maybe a TOR to AOR connection. Also, this Kix region called DB2. We can also trace other things like MQ and IMS, ZOS Connect and CTG and all of those things. This is a fairly sort of simple example here, but we can see that there is far more information here that we can now get the right, certainly narrow down the scope of the problem quicker from that. And the way that we can do that now is not just looking at this nice pretty graph here, but actually we start to drill down and look at the traces that are being captured by the system. So I'm going to start with this issue with this. We're looking at maybe a problem with DB2. So I'm going to go and inspect this issue. So this is something that Instana has determined is a particular problem, and I'm going to recall the event that Instana is wanting to tell us about as it comes up. Come on, there we go. So it's telling me that the robot shop payment service is slow, and we've noticed that problem on DC11, which we know is a DB2 region. So I can go and look at, if we had multiple instances, that would be more instance on this table. Now we look at the details of what this is. We can see when the instance started, when it ended, the time period that it's been running, and the severity of it. We can also look at details in terms of the latency and the transactions observed within this period, and also of all of the calls that went through this DB2 region, how many have been affected by this issue. So from there, I can then actually go and look at individual calls, and it's going to pull me into this system, and it's just a single call in this demo environment here for the time period we're looking at. As I drill down, I can look at the actual traced application all the way from the starting point of the application through all the various systems and then into DB2. So quite a simple example here, but we have a JDBC servlet running. It's observed that it's taken 11 seconds to do this round trip. And we can see the breakdown in DB2 of what actually happened there. We can see actually the connection time was fine. Then we saw it made a lock request on a particular table. Then the application made a second lock request, and DB2 determined that we got into a deadlock situation. So an event was flagged that was an issue there. We can look at each of these different calls in detail on the right-hand side. So here's the basic connect, but also we can look at things such as the deadlock information here. And we get the information that's being pulled back from the SMF records from DB2 in terms of what actually is there. We can also look at what SQL statements or stored procedures were invoked while we're doing that, and then the error that came back from DB2. All of this is really useful information, obviously, for a DBA or systems programmer to go and investigate the particular issue. So we can gather this information up, send it to, and engage the right person to go and investigate and say, look, we've got this problem here that's keeps flagging up for our application on this system. And that's really important, because what we've done here is gone really from a high-level hybrid application, which touches lots of different technologies and lots of different systems all over the place, down to where an alert on the slowdown in that application, and then got down to quite detailed information to understand, yes, actually it's a DB2 problem that we need to look at. And here's the information. The ticket can be updated there. We can give the right context to the person, so they're not looking for any kind of needle in the haystack by saying, hey, we think it's a DB2 problem, go and investigate. We say, well, look, it's this system. Here's some example tasks or transactions that you should be looking at in your system. And they may go in to look at a DB2 tool like Query Monitor or a Megamon to then do more detailed investigation and fix the issue. I want to show one more example on this. So similar application again. In this case, we've got this flow where we've seen some errors going through from the payment to this Tomcat server to Kix, and the database is there. Let's say we think there's a problem. They're all linked together. I'm going to start at the front end with payment, and I'm going to go and look at that issue there. Now, this is a Python that's not actually running on ZOS at all. And we want to go in and look at that particular issue and see what's actually the resulting root cause, or who we should be getting involved with in order to investigate this further. Come on. It's a little slower pulling back the events this afternoon. So a couple of incidents that's identified, and I'm going to jump in, and similar to last time, payment service is slow. We want to look at all of the different calls that are being impacted by that, and we'll drill down, and it's pulling back. It's got a filter here that it's automatically generated. So we're looking at the robot shop application, this payment service, the particular endpoint that we're starting with, and a call that's had a particular extended amount of latency within the system. And I'm going to pick one of those. You can see, obviously, these are very slow transactions. And here we've got the full call stack being loaded in again, and all the different subcalls that contributed to that 20-second delay. So as we look down, we can see, well, actually 20 seconds at the top level, it was 20 seconds at the Tomcat level. As we go further down, we can expand this particular node here and say, okay, actually within Kix, it still took 20 seconds there. And then within the Kix call here to the other region, we've got the call, and we can actually see the delay is between the call to Kix and DB2 here, where we have this particular delay. We can go and look at information about that particular system. We can see some of the slowdown, details of what system was being called. We can see some information about the Kix region. This is information that's been gathered while we've been tracing through the system. So we've got a task number, which is really useful for a Kix systems programmer, and the region there. The other thing that we have here is this infrastructure link. And I'm going to click on this, and it's going to take me through away from an application perspective of the system, but actually to a view of this particular Kix region, and this region called T11A. So we can see the transaction rates and other information that's been gathered about that actual region, not just about the application that we're looking at. This is actually can help kind of validate if there is a particular problem with the region itself, or there's something else that's contributing to our individual application that's being slowed down. Now, this information is coming from a Megamon. We're not gathering this information here. The trace stuff was done as part of our Instana tracing. But what we've done here for infrastructure views is we've actually integrated data from a Megamon. So while you have your Megamon Kix agent running and monitoring the system, and your Kix systems programmer is using a Megamon's UI to go and look at that, we're actually also sharing this data with Instana so that it can also be amalgamated and used alongside the trace information that we're collecting to get a better view of what's happening in those KICS regions. So this means it has a lot of advantages. We're collecting the data once, using it in multiple places. We're surfacing up just really key metrics that will be useful for someone who's doing an initial triage of the problem to determine if there's an actual issue with the region, and then engage the subject matter expert. But it brings a whole extra level of the observability story in there. So we're now just not doing basic application tracing. We're actually integrating metrics coming from the system in order to get a broader view within Instana. Okay. So I'm going to jump into some more slides. So how do we do this? So here's a really basic view of what our Instana architecture looks like for tracing. So outside of the mainframe, Instana is monitoring and managing various different systems. You can deploy Instana sensors onto on-prem distributed services like virtual machines, Linux, Kubernetes, Red Hat deployments. You can also put the sensors onto or monitor cloud-based applications as well. And as you define the application, Instana will trace those. It will create span information and send that back to an Instana server, which is either self-hosted on Linux or within the cloud. But if those applications are tracing through, such as this, if you follow the blue boxes here, we have a web application, which is called a Java application. And then in this example, it made a call into the mainframe onto ZOS Connect, which then called KICS, which then called DB2. The pink boxes represent what we have on or need to be deployed on the mainframe side in order to capture that trace information. So we have agents, data collectors, interceptors, depending on the terminology of the system that's being monitored, to gather trace information. So if we take the ZOS Connect example, as the transaction comes through, our interceptor will look and say, is Instana tracing this application? If yes, okay, we'll gather the information and send it back. Same within KICS, if we'll look at a user exit and say, look, is this transaction being traced? Yes, okay, we'll gather the basic information about it. If not, we'll just let it pass through because we know that Instana is not interested in tracing it. Gather all this information together, we create similar sort of spans that can then be stitched together by Instana so that you get this complete end-to-end view going from this web application on the cloud all the way through to KICS and DB2 on the mainframe. And these are the sort of flows that we're able to trace today. So starting with an application that's being traced outside of the system, maybe it's running on WebSphere, maybe it's a Java application, whatever you have there. We can trace inbound to KICS through things such as MQ, through CTG, ZOS Connect, of course, and sort of HTTP SOAP requests direct into KICS. We can follow those trace flows through different KICS regions. And we can also show if KICS makes a call out to some backend service such as DB2 or vSAM, so that we understand what's happening there. So this is our flow support through KICS. And then through IMS, we do similar flows through ZOS Connect and MQ into the IMS transaction manager, and then onto DB2 or the IMS database in the background. We're working on delivering TMRA support and for sort of user-written IMS clients this year as well, as we build out the ability to trace those flows. And what sort of information do we actually show when we're doing this? So, like I say, when our trace parts are not deep dive monitoring, it's not a replacement for an Omega Mon or anything like that. This is about tracing an application and expanding the flow of a transaction through the mainframe. So we're gathering critical information that will allow you to understand if there is an issue with the transactional flow and give you enough contextual information to investigate further. So taking KICS as an example, we capture the task number, the user ID it was executed under, the elapsed time of the transaction as it spent through Kix, and where it came from and where it was routed to in order to do that. If there's any kind of a bend code issued, we would capture that as well. So that's just essential information to say, look, this is what this transaction did. Similarly for IMS, details around that. I'm not going to claim I'm an IMS expert. My background is far more in the Kix space. And then also on ZOS Connect, the details about the API called, who called it, the service name or the backend service that it's going to be driving within there, and details about the payload as well. Now, for those back-end calls that are coming out the back of Kix or IMS, such as DB2 or VSAM, we would capture information about the elapsed time of that call and the number of calls that are being made to that system as well, so that you understand what's been happening, or if there was an MQ put being made within that. Now, if the MQ put is then picked up by another Kix region, that can also be traced further down the line as well. The other new feature that we've really added in the last few months to our Instana support is the ability to trace direct into DB2 via JDBCs. So we've got those flows through Kix and IMS that I showed a couple of slides back. We now also can show if you've got an application, let's say, being deployed on the cloud or distributed, you've got an application team that's writing some kind of flow, but then they make a JDBC call to DB2 to do a read write of some system of record on the system. So we've added that support to be able to trace that directly in, and that is similar to the deadlock example I showed earlier. We're able to show some detailed tracing within DB2 by gathering details from the SMF records, and we're able to identify where the time was spent within DB2 if there is a slowdown in that application. So the amount of time that was spent doing a connect, what SQL requests were being issued, what if there was a lock or a timeout or a deadlock that occurred there as well. Okay. And I also talked a little bit about our integration with a Megamon. So a Megamon is not a prereq for any part of the tracing. However, if a Megamon is available, we can add selected data from a Megamon into Instana to give you additional metrics, infrastructure view of the system. The way it works is we use a newish component called the Megamon Data Provider, or ODP. That is able to pull data from and periodically collect data from all the Megamon agents that you may have running, similarly to how a Megamon's history works, pulls it into this data provider process. And within there is a YAML file that says, these are the particular attribute groups that I'm interested in gathering, and send them to Instana. So a Megamon will gather the information and then push it over to the left here, where we have an integration proxy that's gathering the Megamon data as it comes in, and it turns it into, so it acts like a native Instana agent. So as if we're collecting the data directly via Instana and feed that into the Instana server so that we're able to then display that. And we've provided predefined dashboards so far for Kix, for the ZOS agent, for the JVM agent and the MQ agent so far on a Megamon, and we're going to be adding more this year so that there is a native out-of-the-box integration between a Megamon and Instana. And this is really my last slide on where we are with Instana. So I mentioned that IBM acquired Instana a couple of years ago. At that point, there really wasn't any true integration between Instana and the mainframe, which is very typical of a lot of observability solutions. But what we've done is made sure that for real enterprise level customers who are having the mainframe as part of the their infrastructure, we're making Instana ensure that it has the best of breed ZOS and Z support generally. So when the Z16 was announced last year, we spoke a bit about what we had already available with our Instana investment on Z, but also where we're further investing on that. So I've already shown a little bit about the integration with the Omegamon agents. We've also delivered and continue to deliver more tracing capabilities. So we've done inbound tracing via MQ into Kix and IMS. I mentioned all of the different Omegamon agents we so far integrated. The other area that we are looking to deliver is make more of the capabilities available for Linux on Z as well. So that would be if you wanted to do a self-hosted Instana deployment of the server, run that on Linux on Z as opposed to Linux on x86. And also our other components within that currently run on Linux x86, make them run on Linux on Z for customers who've got Linux One, IFLs, ZVM, and want to make use of the capabilities of the platform to host their Instana capabilities. So that's where we are today. My sort of final few slides are going to be around sort of a bit of a discussion or overview of potentially where we're going with a lot of these things. I think what you maybe have seen with what we've shown today is, and you may be sort of familiar with this within your own organization, is that within observability, what we need is not sort of disparate APM monitoring tools or log analysis tools, but something that can pull all these capabilities together so that we have real visibility into the sort of support and needs of multiple personas across the business. So application owners, SREs, even the mainframe operations team as well. Because when you have a real end-to-end view, you don't have disjointed perspectives that lead to, increases the mean time to recovery from operational problems. And the real challenge to get this done at an enterprise level is that often you've got solutions in place that do parts of the story, but don't really pull everything together because they're often quite disparate proprietary technology stacks. You may be having different business units that pick certain technologies. So one picks, one solution, someone picks another else. Maybe some of your tooling is based on when SOA was the cool thing to do, but now you've got to integrate new applications developed through microservices. Or maybe there's a merger or acquisition within the organization and data centers are being consolidated. All of those things feed into decisions around operational tools, and you need to pick something, but often there's not a perfect fit. And we've been striving to overcome that for years. And having these incompatible solutions often becomes a major inhibitor when it comes to real quality observability and trace and the ability to manage those incidents. So as with many aspects of IT over the past decade, open standards seem to be leading the way here. There is a standard out called OpenTelemetry. It's been published particularly for the tracing capabilities, and it's really coming together now from metrics and is in draft for logs. And what OpenTelemetry points at is a standard that we can work towards where any OpenTelemetry compatible solution should be easily able to add observability to software or technology that's producing OpenTelemetry spans or information. So this is not going to be an overnight solution, but it really has been growing on the distributed space. It's been noticeable. So if we look at some of the amount of work that and contributions to certain open standard technologies, OpenTelemetry is really up there alongside Kubernetes and other standards and solutions that are being really looked at in quite detail. And you'll find that most observability solutions today, including Instana, claim some level of support in terms of traditional proprietary capabilities. So this is an area that's going to move forward pretty quickly over the next couple of years. I just want to spend a couple of minutes just to go into a little bit more detail around what OpenTelemetry is and kind of what it isn't as well. So it provides a standard set of vendor agnostic SDKs, APIs, tools for ingesting, transforming, and sending data to an observability backend. And that can be an open source thing like Jaeger, or it could be a commercial solution like Instana. It's not an observability solution in itself. So it's a standard around that, and it's a set of processes to follow. So that means that systems or infrastructure or applications can develop vendor agnostic instrumentations or telemetry data about what they're doing and performing, irrespective of the observability solution that will ultimately consume the data and probably do analysis on it and display the information. At the center of this diagram here is the OTel collector. It removes the need to run and operate multiple agents, collectors. Typically, you'd have a local collector agent which has instrumentation libraries to export their telemetry data, and you send it to there using a standard protocol, and then the collection data can then be forwarded to a targeted front end to actually consume it. For tracing, so transaction tracking, tracing data, the systems will provide a tracer implementation, and that creates the spans that create more or contain information about what is happening for that given operation, such as a transaction request. What's important is the information around the spans will enable a correlation between different systems or spans created by different systems, using some metadata called the trace context. It captures sort of an idea of an overall transaction, and then the calling spans. So ultimately, when all these informations come together, they can be traced together. So what does this mean for the mainframe? We're kind of at the start of this journey here. We're not short of different ways to share data about system performance on the mainframe. We've got things like SMF records. We've got agents for monitoring solutions from many different ISVs, not just IBM. I don't expect that to change anytime soon, and probably not that the ZOS and all key subsystems will magically start emitting OpenTelemetry data directly for consumption. But what I do see is, particularly in the tracing space, a move towards what the mainframe could and should be providing through OpenTelemetry standards to help us have a full end-to-end hybrid application observability. I'd be really interested if any of you have more interest in this space, and please do reach out to me, because I'd love to get some feedback on what's important in terms of this domain. We're going to need to work towards solutions that are gathering, tracing metrics and logs and SMF data to make those insights available for OTel compliant solutions. Maybe that goes through a single gateway to get to the system. There's going to be a lot of work in terms of getting the tracing to work across different technologies as well. But it's definitely an area that's going to be worth watching over the next couple of years. So as I say, please do reach out if this is something that you see is going to be in your future within your organization, and would like to discuss that with me. Okay, so let's finish up. I hope this presentation has been helpful for you to understand what observability is, especially in terms of the context of enterprise-wide observability and why it's becoming a bigger topic for larger organizations in particular. We see more and more of our clients developing hybrid applications that might include a cloud-based front end, traditional on-prem IT, like the mainframe. And many of the benefits of pulling all of these things together is undermined when it comes to systems management. If you've got an application problem, it becomes time and resource consuming to detect and isolate those issues. And often the blame game suddenly ends up between teams, because you have to prove or refute responsibility for the problem. And the lack of a joined up insight, data does nothing to help your management of those applications. If you don't have consistency across that telemetry data, or worse yet, blind spots, such as a lot of people do with the mainframe, the impact to business applications is really self-evident there. So the emergence of observability solutions, those that can combine things like tracing, metrics, and logging has been quite noticeable over the last couple of years. It's being driven by the application need for an application-oriented perspective versus a more infrastructure-oriented perspective. These solutions really do focus on discovery of what the application is doing, context for the application, collecting all that information together, and that will lead to an improvement in terms of mean time to detect, mean time to resolve a problem. What is still largely true, though thankfully that's changing, is that the mainframe is not always considered a first-class participant of such observability solutions. You've got some great stuff that shows all of the front-end VMs and things, but then you go into a black box when it comes to the mainframe. And with business-critical workloads and key business data running on ZOS subsystems like Kix and DB2, it's really essential that we get that full end-to-end insight as we go through there. So this has been useful. I've got a few links at the back, and email address if you want to reach out afterwards. I have uploaded the slides last night, so they should all be there for you to download. And there's some example screens versus the demo that I showed today on that. And I guess Anna will remind me that to fill out your feedback forms for our sessions after this session finishes.
I will indeed.
There you go.
Thank you, Chris, and thank you, Nicole. If anybody wants to ask a question, you may now unmute yourself so that you can ask person to person. I didn't get any questions in the chat, so I can't relay those. So,
my
yes.
throat is giving out as well, so. If there's not, then thank you for spending time with us today. Oh, that was fun.
Just thanks, interesting talk. And,
okay, thank you.
I agree. Okay, so people are now starting to depart. So I think we can safely say that this session is concluded. Thank you very much for providing it. And thank you everybody that joined for listening.
Thank you very much.
Thank you.